Hello, I'm Vidya and this video is in continuation to my previous video on Caesar Cipher where I've explained the concept of Caesar Cipher and taught you how to solve a numerical. So I've briefed you on the steps in the previous video. I would request you to kindly revise the steps in the previous video whose link is given in the description. So we would first revise on the formulas of Caesar Cipher. If P is the plain text, K is the key and C is the cipher text, then the encryption formula of Caesar Cipher is given as C is equal to P plus K mod 26 and the decryption formula is given as P is equal to C minus K mod 26. Why do we use mod 26 here? I've explained it in detail in previous video. Kindly scroll through that video for better understanding. Since Caesar Cipher uses the mathematical addition operation, it is also called as additive ciphers. So let us go ahead with the following numerical. Encrypt the given plain text Caesar using key 15. I've taken the similar numerical in the previous video where plain text was Caesar, but there I've used a key of 3 and hence there was no complexity when we were solving modular arithmetic. Here the difference is that I've taken a key which is 15. As I briefed you in the previous video, the first step that we have to do is, because the formula of encryption is given as plain text plus the key mod 26. So we are doing mathematical addition. Our key is 15, which is a number, but our plain text are letters, and hence we have to map each letter to numbers, for which we require mapping table. So a step 1 is that we should use table which maps the letter to the numbers. For example, these are the letters. I should map these letters to numbers. So A is mapped to 0, B is mapped to 1, C is mapped to 2, D is mapped to 3, 4, 5 and so on. You give numbers to each of the letters here till you reach Z, and Z will be 25. This is exactly the reason why in the formula of ciphertext we use mod 26, because we have a total of 26 letters ranging from 0 to 25. So we are working in a finite field of 26 numbers and hence we use mod 26 for encryption. So first step of solving any Caesar cipher question is you map the letters of the plain text to numbers. So in step 1 of encryption using Caesar cipher, you create the mapping table. In step 2, you create a table having 3 columns. In the first column, you write down all the plain text letter. What is the plain text letter given to us here? It is Caesar. So write down the letters C, E, A, S, E, R. Now we need numbers representing these letters. So the numbers representing these letters will come from the mapping table. So you see this mapping table on the left hand side. So C is represented by number 2, E corresponds to number 4, A corresponds to number 0, S corresponds to number 18, E corresponds to number 4 and R corresponds to number 17. So after having mapped each letter of the plain text to its corresponding number from the mapping table, we now go to the computation. The key that has been given to us in this question is 15. So we'll use 15 as K. So in computation, we generate the ciphertext by addition of plain text number and the key using mod 26 arithmetic. So let us see how do we do that. So our first plain text number is 2. 2 plus 15 is 17 mod 26. So since 17 is less than 26, we keep 17 as it is. The next number is 4 plus 15 comes out to be 19 mod 26, and since 19 is less than 26, 19 remains as it is. The next number 0 plus 15, which is 15 mod 26. Again, since 15 is less than 26, 15 remains as it is. Now 18 plus 15, if you do the addition, you get the answer as 33 mod 26. Now you check, 33 is a number which is greater than 26. So you have to apply modular arithmetic. How to solve modular arithmetic? I have created a detailed video. Kindly check that out so that your concepts on modular arithmetic are clear. However, here I'll explain you how to solve 33 mod 26. So you basically have to divide 33 with 26. Whatever remainder you get, that is the answer of the modular operation. So 26 into 1 is 26 and you are left out with the remainder 7. So my final answer is 7. So the answer of any modular operation is basically the remainder. So 33 mod 26, the remainder is 7. So 7 is my answer. So the next number is 4. 4 plus 15 comes out to be 19. Since it is lesser than 26, you will keep it as it is. So you have to do the modular arithmetic operation only if the number exceeds 26 or if the number is negative. Next number is 17. So if you do 17 plus 15, the addition comes out to be 32. You see that 32 is a number which is greater than 26. So you have to perform mod operation here. How do you perform mod operation? You divide 32 with 26. 26 into 1 is 26 and the remainder that you get is, so the remainder is 6. So 6 is my answer for 32 mod 20. So I got my ciphertext numbers. The next step is that we have to map each of these numbers to its corresponding ciphertext letters. For that we require the mapping table. So we'll make use of this mapping table and convert these ciphertext numbers into the corresponding letters. So 17 corresponds to letter R, 19 corresponds to letter T, 15 corresponds to letter P, 7 corresponds to letter H, 19 corresponds to letter T and 6 corresponds to letter G. We have mapped each of the number to the letters using the mapping table. Therefore, the final ciphertext that we got for the plain text Caesar is RTPHTG. So for the plain text Caesar, we have now recovered the ciphertext RTPHTG. Let us now see how will we decrypt this given ciphertext using the key 15. So as I told you, the first step is you should use mapping table because Caesar cipher works on numbers and you have to map each letter of your message to a number so that it can process it. So we have to use first step, which is mapping the letters with numbers. In the second step, as I told you, create a 3-column table. In the first column, you write down your ciphertext, that is R, T, P, H, T, G has been given to us. Now for each letter, you write down its corresponding number. So R corresponds to number 17, T corresponds to number 19, P corresponds to number 15, H has a number 7 assigned to it, T has a number 19 assigned to it, G has a number 6 assigned to it. Now the formula that is used for computation is C minus K mod 26. So we have to do modular subtraction now. For encryption we did modular addition and for decryption we have to do modular subtraction. Let us now see how to do modular subtraction, which is required for Caesar cipher decryption. The key which has been given to us is 15. So every time we have to subtract 15 from each of the ciphertext letter. So let us start with the first number now. So 17 minus 15 comes out to be 2 mod 26. And as I told you, since 2 is a number less than 26, your final plaintext letter is 2. To perform modular arithmetic, you have to perform it only for two cases. One, if your addition exceeds 26. Second, if you get a negative number. Then we go ahead with performing modular arithmetic. If the number is positive and if it is less than 26, you retain it as it is. So the next number is 19. So 19 minus 15, we get it as 4 mod 26. Again 4 is less than 26, so we keep it as it is. The next number is 15. We subtract the key 15 from it. So 15 minus 15, 0 mod 26. Again 0 is less than 26, so we retain it as it is. The next number is 7 minus the key which is 15. So 7 minus 15 is minus 8 mod 26. Now the number is negative minus 8. Therefore, you have to apply modular arithmetic. As I told you, you will apply modular arithmetic in two cases. The first case is if you get the resultant is positive and it is greater than 26. Second case is when the resultant number is negative. Now we got negative number. So how do we solve? Since I got minus 8, I will just add 26 to it. So the answer that I get is 18. So 18. So what you get here, the answer is basically 18 mod 26. If you do minus 8 mod 26, the resultant answer is 18 mod 26, and 18 is a number which is less than 26, so your final answer is 18. The next number to be encrypted is 19. So if I do 19 minus the key, which is 15, my answer is 4 mod 26, and 4 is positive and it is less than 26. So the final answer is 4. The next number to be encrypted is 6. So if I do 6 minus 15, I got minus 9 mod 26. So as I told you, because you got a negative number, you have to do modular arithmetic now. How do? You take that negative number minus 9, add 26 to it, because we have been asked to do mod 26 operation. So you add 26 to it, and the resultant that you get is 17. So you got 17 mod 26. Now 17 is a number which is less than 26. So your final answer is 17. The next step here is to map each of the plain text numbers to its corresponding letters, for which now we need the mapping table. So once you have your mapping table, you can assign the letters to each of the plain text number. For example, number 2 corresponds to letter C, number 4 corresponds to letter E, 0 corresponds to A, 18 corresponds to S, 4 corresponds to E, and 17 corresponds to R. Therefore, the cipher text RTPHTG, which was given to us, has now been decoded using the key 15 as Caesar. So we have successfully decrypted. So the formula that we used for encryption was modular addition, that is P plus K mod 26, and the formula that we used for decryption is modular subtraction, that is C minus K mod 26.